Let's just go back here. That way the first thing that people see is the lesson. Okay. So, function and relation. Everything that we do has some type of relationship, right? We've talked a lot about it in biology, or if you're going to take biology, we'll talk about it there. You probably talked about it in 8th grade in some type of science. There are relationships between organisms, right? There's good relationships between organisms, bad relationships between organisms. In everything that we do, there is some type of relationship, and that's especially in mathematics, right? When we talk about relationships, that's big picture. Then we talk about other types of relationships, right? Symbiotic relationships that are good for each other. I'm not too keen on the other types of relationships for science that are bad for each other. But as we keep progressing, we get into more specifics. That's the same thing with math. We have relationships. We have a coordinate grid. Right? We have our coordinate grid. It looks something like this. And every time we have some type of input, when we put in something, we expect to receive something out, right? That is how it is in math, right? And we've seen different types of input-output relationships, right? We've seen some of them that when you input something, you get something out. However, imagine for a moment, we're going into the teacher lounge vending machine, which we're not supposed to go in there, only me, right? But imagine you go in there, right? And man, I ran late. I didn't get breakfast, so I'm really looking forward to that Pop-Tart. But imagine I take my time. I'm like, okay, I put my money in, and I type in the keypad, D4. What's your expectation? Someone raise your hand. What's your expectation? I want my Pop-Tart, right? But imagine for a moment that I put it in, I get D4, and I get corn nuts. I'm upset. I was really looking forward to my Pop-Tart, but I ended up getting corn nuts. So imagine for a moment, this is my Pop-Tart, and imagine for a moment, this is my corn nut. Whenever I put in this input, and input's always my x, right? Inputs are always my x. When I input that value, I could either get my Pop-Tart, and let me finish it, Pop-Tart, or I could get my corn nuts. Would you go back to that vending machine? Heck no, I wouldn't. Jeez. I'm expecting something when I put in that number, right? So think of it like this. In mathematics, there are relationships. Relationships between values. Bless you. And let's get more specific, right? When we talk about these relationships, they could have two outputs. What do we call something that's more unique, that every time I put in an input, you get only one output? What do we call that in algebra? A function. Very good. This is what we call our function machine, right? Where there is a set of rules. Now, let's go back to the vending machine analogy. If now we call this vending machine a function, every time I put in the code for the Pop-Tart, what's the expectation? I get my Pop-Tart. That is how functions work. For every input, there is one output, just like a vending machine. So every time you think of a function, think of a vending machine. Okay? Now, in Algebra 1, going back there, we talked about 3 functions. We will still talk about them in Algebra 2, but let's revisit them. We talked about, what do we call our line function? What did we call it in Algebra 1? Linear, very good. What did it look like? Straight line, right? What about our U-shaped function? What did we call that in Algebra 1? Someone else, raise your hand. It looks something like this. What do you got? It is quadratic. This is my quadratic function. And last one, we talked about another one. Shot straight up. Anybody remember? It's been a minute, I know. It looks something like this. I think it looks like the letter E. And that's how I remember it. What is it? Exponential function. How did I know these were functions? Well, we drew a line, a vertical line. What did that vertical line tell us? That for every input, there's how many outputs? 2, 1, question mark? How do we say something is a function? What does our vocab tell us? What values do not repeat? X values. So for every input, X, how many outputs am I expecting? 1 output. That's how I know something is a function. I would write that down. I would underline it because that's kind of the base of algebra. We deal with functions. And how do we know something is a function? For every input, there is only 1 output. Now, for one-to-one functions, we're going to talk about this. There's something even more specific behind functions. Let me just move this down. There are one-to-one functions, even smaller. So for functions, x's can't repeat. In order for something to be a one-to-one function, the y values cannot repeat either. And I'd underline that, highlight it, whatever you need to remember, because again, that's important also. So for example, on here, it tells you that it must pass some type of test. We heard about the vertical line test in Algebra 1. We're introducing a new type of test just to see if a function is one-to-one. It's called horizontal line test. And it sounds just as straightforward as it sounds, right? I'm drawing a horizontal line. Meaning what value cannot repeat? The y value. Again, underline it, highlight it, very important. We don't deal with too many one-to-one functions, but it is important for you to know the difference and why something would be a one-to-one function. Can I answer any questions? Okay. Why bother talking about relationships if we're just going to deal with functions anyway? Right? If we're going to just talk about functions, why do I even bother talking about relations? Right? I'm going to skip this example because I want us to talk about keeping up with temperature. Right? Let's say for a moment we are tracking the monthly average water temperature in the Gulf of Mexico. In January, the water temperature is 69 degrees. In February, 70, March, 75, April, 78. How can we represent this? Well, let's plot our points. In January, I'm looking at 69 degrees. In February, I'm looking at 70 degrees. March, 75. And April, 78. Cool. Are we okay so far? Have I done anything that's just too much, right? So we're going back all the way to 7th, 8th grade plotting points. I want you and your groups to talk about, if I wanted to create a relation, meaning what repeats if it's a relation? The x or y. Y's can repeat, but specifically we're talking about x's. If my x repeat, what would this look like and what would be the context? Think about that. I want you and your group to talk about it for 2 minutes. If I wanted to create a relation, meaning my x repeats, how would that look like on the graph and what's the context here? What would I be tracking? Go. Well, that's a function right there, right? Well, what if this has to be a relation? Yes, right? So then in January, that could be any other factor, right? What's the context? That's right, talk about it. If you would like, I'm gonna give you access to it. I just want you for this, I just want you to just look at it doesn't have to. But that's what I mean. That's the whole reason why we can't call it a function. Because there's repeating. You can call it a relationship, sometimes a relationship. But I wouldn't be able to call it a function. Alright, everybody, let's talk about it. What are we even measuring here? First, question mark. Temperature, right? And in what intervals are we measuring the temperature in? Monthly intervals, right? Okay. So let's put it in context. I'm measuring the temperature in Florida. Right now that's a big topic, right? The Hurricane Aaron, right? Those of you tracking it, right? It's now passing the East Coast, right? How do hurricanes form? Hot waters, right? That's pretty important. So let's talk about it. Let's put it in context. Let's say for a moment, I measured the temperature of the water in January and it's 69 degrees. Well, we said that hurricanes are formed in cold water or hot water? Hot water, right? So if you're a meteorologist, in January, you know, or do you think there's going to be hurricanes? Probably not. And again, I'm just basing it off context, right? I'm measuring the temperature in the water and it's 69 degrees. Let's say, miraculously, right, we're measuring another temperature and it's 74 degrees. What's the context here? It's hot. Am I still measuring it in the same location though? Ooh. If we're already saying that in the Gulf of Mexico it's 69 degrees, could this still be true? Am I still measuring it in the Gulf of Mexico? Probably not. Quinones. Okay. I don't know. Thank you. Let's add context, everybody. Let's say we're now in... Hold up, I want to be accurate about this. Let's look at another part of the globe close to the equator. Hold up. Let's go... What's up? Yes. Let's say this is the Western Sahara. Now we're putting into context, right? Think about it like this. Think about a relation or a function like chat. Think about it like ChatGPT. ChatGPT only functions if you give it specific instructions, right? For example, hey, help me solve this math problem. It's only going to show you that math problem. That's a function. It's only giving out what you input. That's the rule. Now think about it in relation. Hey, I want you to give me the temperature not only in the Gulf of Mexico, but near the Western Sahara. What's it doing? It's giving you two outputs. It's giving you this as the Gulf of Mexico, and then it's giving you this also in the Western Sahara, right? Why? Because you have told chat, I need you to give me this. It's functioning based off of the rules that you've given it, right? That is how a relation works. That is how a function works. Based on how it operates and the specific instructions, it is going to react a specific way. How do we feel now? Now it's starting to connect. It's starting to click, right? So if we were to keep going over here, okay, yes, Chad is operating with two things in mind: the Western Sahara temperature, the water near it, and the Gulf Coast, the Gulf of Mexico temperature, right? So this is a relation. Yes, it's doing both of these things, but this is why we still need relations, right? Because if we're asking for multiple things at the same time, it's way more efficient than just saying, Chad, give me the temperature of this, and boom, it only gives you one output. That would take you a long time for you to do. That's why we still use relations now. That's why we don't just stick with functions. But understanding the differences between what a relation is and what a function is crucial here in this class. How do we feel? Can I answer any questions? Okay. It is important now that we identify a function based on a couple different things. Three things to be specific. One, a mapping diagram. You need to be able to tell whether or not a set of points is a function or not a function. Okay, so let's take a look. I'm going to do the first one for you. I want you to always know, unless you're told otherwise, this is my input and this is my output. A lot of other things can go under. This is my x, this is my y, my domain, my range. Several different things can be said. And if you aren't told anything, the expectation is your left is your input, your right is your output. This could also be like your homework, set A, set B. Right? A couple different things. But let's talk about it. What did we say? Which value cannot repeat if it is a function? The x. So we are going to focus our attention on these three numbers. So when I input the number 3, what comes out of chat according to this mapping diagram? -2. Is that the only number that's generated if I put -3 into chat? Yes. So okay, we're good so far. Let's look at the next one. If I put in a 0 inside of chat, I guess we're gonna call functions chat now. If I input 0 inside of chat, what's gonna come out? What's my output here? 7. Does anything else come out of chat? No. So we're good so far. Last one, just to see. The number 4. If I put 4 into chat, what's going to come out? 1. Does anything else come out instead of just 1? So my question to you is this a function? Yes. So this is a function. Now, in order for it to be 1-to-1, let's reverse. Let's look at the output. I'm going to focus, and I'm just going to erase this. We're going to focus on these three numbers. Imagine if the arrows were flipped for a moment. If I were to put in the number -2 inside of chat, what would spit out? -3. Okay, we're good so far. What about the number 1? If I were to put it into chat, what comes out? 4. Okay, and what about 7 if I were to throw it into chat? 0. Do any of the outputs repeat then? No. So is this a 1-to-1 function? That's how you do it. So I want to test you. I want you to do the next example with you and your group mates. I'm going to give you about a minute. It shouldn't take you that long. How could you tell if this is a function? If it is a function, is it a 1-to-1 function? Question mark. So 60 seconds, go. All right, everybody, here we go. A minute has passed. Let's talk about it. Can we even call this a function? You're saying no, but what is your evidence? Let's look at them just as we go for it. 4, okay, goes to -1. Oops. Okay, we're good so far. 8 goes to the number 6. Seems like a function to me. 1 goes to -1. My yellows haven't repeated yet, so far a function. 6 goes to 6. Still haven't repeated. But as we get to this last pair, which input ended up repeating? 4. Because my 4 repeated, not a function. Boom, done. I don't even have to worry. I don't even have to care if this is a one-to-one function. It's not even a function. So I don't bother. We're done. This is not a function because when x equals 4, y equals -1 and the number 1. So it doesn't work. Did anybody find another way to do this instead of just going down? Did anybody create a mapping diagram like the one we did? Good. That is another way. If you cannot visually see the points and you would rather do a mapping diagram, it works the same way. Here's why. We had the number 4, -1, 4, 8, 1, and 6. I don't bother writing that 4 again. As long as that number is represented in that set, we're good. But what numbers do I write for the other side? -1, 6, and the number 1. Right? -1, I already got it. 6, I already got it. And the +1. So let's look at the mapping diagram. 4 goes to -1. Good. 8 goes to 6. 1 goes to -1. Not an issue yet. 6 goes to 6. But then 4 goes to +1. Here's the focus. If you see 2 arrows, 2 mapping arrows come out of the input set, it's not a function. Why? Because there's at least one number that has multiple mappings to the output. That's why. And that'll be relevant into your homework. That's why I'm saying it that way. Okay? So good. I would also suggest that you can make a mapping diagram from this. Okay. Visually, problem 3. Is this a function? Yes or no? No, it is not a function. Which is the number that does not allow it to become a function? 2. How many mappings does it have? 1 to -3 and the other one to +3. This does not allow us to be a function. Okay? This should be example B. Is that ordered set of coordinate points a function, yes or no? It is a function. Well, let's look. -7, 9, 14, +7. So far, nothing repeats. Looks like we're good. So yes, this is a function. Is this a one-to-one function? What value repeats? The 14. And that 14 is in the x or the y space? The y. So again, quick rule. For functions, x cannot repeat for one-to-one functions. Y cannot repeat. That is the shorthand. What's up? Very good question. If it's not a function, then we can't even say it's a one-to-one function. So it has to meet the first condition. It has to be a function. If it is a function, then the question is it a one-to-one function? Good question. Anyone else? Okay, let's look at the last slide that I have for us today. Now we are using vertical line tests. But I don't just want to look at vertical line tests because according to our vocab, what other type of test can we check to see if it's a one-to-one function? Horizontal line test. Before we get into these, I want us to look back at the 3 parent functions we talked about in Algebra 1. We said those were linear. We also said quadratic. Someone remembered. Good. I know it's been a minute. And maybe your experience was great or not. And let's look at the last one. Our exponential function. Let's check to see if these are one-to-one. Well, we already know their values. Their functions, right? How can we test that real quick? The line test, our vertical line test. If we draw a bunch of vertical lines and that vertical line crosses the graph, the red one, once, function. So this is a function. Good. This is another function. This is another function. Again, let's look back at our 3 parent functions that we talked about in Algebra 1. Let's check to see if any of them are one-to-one functions. All we have to do is draw what type of line to see it. Remember, what value can't repeat for a one-to-one? The y value. So all we have to do is draw a bunch of horizontal lines. Is our linear function a one-to-one function? Yes. Every single input has a unique output and every output has its own input. Never repeated. So this is a one-to-one. However, let's look at our quadratic function. What do you notice? The y repeats. In the majority of the lines, if I were to draw a bunch of horizontal lines, the majority of them will have 2 different outputs, right? They'll cross the graph twice. So this is not one-to-one. And I know you can't see it based on the graph, but I'm telling you, an exponential function is considered a one-to-one. Every input is going to have a very slightly different output. Right? It's very decimal based. It's very small change. But an exponential function is considered a one-to-one function. Okay? But now let's look back at these. Example A, is that even a function? No. I draw a line here and I get 2 intersections right here. This is not a function. And just like Genevieve said, if it's not a function, it can't be a one-to-one function. So we don't even bother. Okay? What about B? Is this a function? Yes, look. No matter how many vertical lines I draw, it's only going to touch and cross once. So we're good. However, what if I were to draw a horizontal line? Is this a one-to-one function? A great question is also, Mr. Quinones, what if I would have drawn the horizontal line here? It only touched it once. True. But for those of you that took me in geometry, I'm telling you that a one-to-one function has a unique y value, right? It's never repeated. So it can't just be true once. It has to be true always, every single time. That's why I draw multiple lines, to prove it to you visually that it's a function, but also to prove it to you that this is not one-to-one. Because yes, at one point it's a one-to-one, but as we keep drawing horizontal lines, it's not. It has to be true for every single line that I draw. Okay? Same thing with this last example. Let's take a look. Is this a function? So I don't bother to keep going. Problem 4, function. Boom. The moment it fails the vertical line test, we're done. We don't have to keep going. One line is sufficient. B, let's take a look. Is this a function? Okay. Is this a one-to-one function though? What ends up repeating? These 2 points right here. So not one-to-one. And last one, is this a function? Yeah, no matter how many vertical lines I draw, it will only touch that graph once. However, is this a one-to-one? Believe it or not, there's going to be several scenarios where it'll never pass a horizontal test. It might even cross it 1,000,000 times, right? An infinite amount of times, some would say. So yes, this is a function, but it is not one-to-one. And I gave you an example, 2 examples of functions that are, or graphs that are functions, and they are also one-to-one, which 2 of them we've already talked about in Algebra 1. Questions, anybody? How do we feel? Good. Okay. There's a Delta Math assignment for you. Go ahead and work on it. Take the rest of the class. Remember, it's due Sunday, 9 p.m. Okay?